Hi, this is Steve Barton for Solid Rock Machine Shop Incorporated. We just produced a video on the coolant. We got it changed, and now we want to grind this magnet, resurface it, get it trued up, and that's what we're going to do today. One of the things I forgot to mention in the video on the coolant is if you you see we mount this coolant tank on these boards. The reason I do that, again, is another variable that I want to control. It's a metal container. If it's down on this concrete, both have very good thermal conductivity. And what will happen is this floor is cooler than, say, this area up here where we have our gauge blocks. And there may be a few degrees difference. If you're going to do high accuracy work, that little bit of variable you control there will make a difference. At my full-time job that I've had in many different places, they usually have their tanks right on the floor, and I can remember OD/ID grinding a lot. I could feel that the parts were physically colder coming off the machine, than what the room temperature is. So if they're extremely fussy parts, plus or minus a tenth or two, and you measure them when they're colder, and you're measuring them and your gauge blocks are warmer, the thermal expansion in the gauge block, which is your measuring device, is greater than the part that came off. That few degrees can make all the difference between a part being in tolerance and out of tolerance. So we found it quite often that if you would grind a part with a cold coolant that was much colder than your gauge blocks, you checked it, you come back the next day, and that part warmed up to the room temperature the same as the gauge block, there might be a tenth or two expansion, maybe even a little bit more, and it may throw your part out of tolerance. So when you're really fighting to get some of the extreme accurate parts, a little bit of difference like this will make a huge difference, because you got a barrier between the floor there, and it does help out a lot. Also, one of the things with some of the synthetic coolants, the reason that we're using a water-soluble oil over here is because my son Adam is quite allergic to a lot of the coolants that we were using, and he was so allergic that you can just, where if he'd get a little spray, a few droplets that would hit him, his skin would actually turn red. I'm not as allergic, but what is typical with a lot of synthetics is that they will attack the mucous membranes, and so as this stuff is misting as you're grinding and you're breathing some of this stuff in, it can affect that. Next thing you know, you got some sinus troubles. It would affect me and quite a few other people I know, to the point that when you blow your nose, you're blowing blood. With my son Adam, he would even be coughing blood after exposure for a number of days. So if you got some coolant and you're experiencing the sinus problems where you're blowing blood and stuff, that coolant's probably the culprit. I definitely change it. And this coolant, so far Adam hasn't had any problem with it. I definitely haven't had any problem with it, and I've been out here quite a bit using it. Some of the papers that I'm posting on the previous video we did on changing the coolant, you can read through those papers and they'll talk about some of those safety precautions with the coolants too. So anyways, back to grinding the magnet. There's many videos that I've seen on the internet or people, they're wanting to grind it, and again, because they're new at this and they just really don't know the ins and outs, you'll see them, they want to start with a fine wheel, 80 grit wheel or something like that, and they want to grind this magnet. They're wanting a good finish on the magnet. Well, really, you don't need the finish on the magnet. What you need on a magnet is that it's flat. It's going to be a lot harder to get something flat with a very fine wheel, because it's generating so much heat. It's going to be hard to get it flat. We don't care about the finish, because as you pull your parts on and off, it's going to get scratched up anyway. That's where you can take those stones that we've been making, that Robin Rincetti got his keyed on. You can use those stones, take them little scratches and defects out of your magnet, and that's the main reason that I made those stones. So anyhow, one of the videos we watched, he started out with an 80 grit wheel, and he'd come across and he thought he would switch to, I think it was either 120 or 150 grit for his final grind. And I knew he was going to have problems, and sure enough, he got about halfway to 3/4 of the way, and all of a sudden he started burning the magnet. With that coarse wheel, there's not enough room for all the particles, that, especially from soft steel, that's going to get wrapped around each of those grit. There's not going to be enough room, and what happens, you're going to eventually have metal rubbing on metal. You're not going to have a cutting action, you're going to have a rubbing action. When you have a rubbing action, you're going to have a heat buildup, and you don't want that in your magnet when you're grinding it. So if you've got a 46 grit wheel, this is my favorite that I'm using right here for grinding a magnet. I always like to use a brand new one to start with, but this is a 46J. I think maybe if I went down to an I or an H might even be a little bit better, but this one works fantastic. I've been using it for decades and I've never been disappointed yet. So it's a 46.2 from Radiat. So it's a 46 grit, and 0.2% of this is a finer grit. I don't know what that grit size is. I don't know if you can find out from their website or not. I haven't checked into it. But I like to use, start out with an 8-inch wheel as close as I can. And the reason I do that rather than starting with a small wheel is if you've got the circumference of an 8-inch wheel compared to the circumference of something, say on this diameter, 4 inches, you have way more cutting edges. Each piece of grit has a cutting edge. You have thousands more cutting edges with that 8-inch circumference than you do a smaller. And when you're grinding a magnet, you want to have every advantage you can. Because what happens is, even though you're taking a little bit off on a magnet, you're taking off an area, in this case, it's almost 6 by 18. It's probably about 5.5 by 17, I'm guessing. I haven't actually measured. But you're coming across that entire magnet. That's a lot of steel, even if you're taking a thousandth off, it's a lot of steel. Now when I chew up a magnet, I'm never even taking a thousandth. The max cut I will take is about 2 or 3 tenths. You start taking more than that, by the time you start getting about halfway across, you're going to see that wheel loading up, and it's going to cause you problems even with a coarse grit. Now, if you don't have coolant, I would recommend going with something that's porous. A wheel we talk about, I would go with a open structure wheel if you do not have coolant, because your biggest enemy here is going to be heat buildup. So this will grind a lot cooler. You may have to take more dresses on it, more lighter finish passes, but I think this one will be the wheel you want if you don't have coolant. If you got coolant, this 46.2 wheel works great. Before we started the video, I ran the coolant for about 15 minutes on the magnet, trying to get the temperature stabilized with the coolant temperature so the thermal is fine. I already dressed the wheel, and what I'm going to do is I'm going to grind the magnet now. And when you grind your magnet, you always want to grind the magnet in the same condition you're going to use it, which is on. Some magnets, it probably won't make a whole lot of difference, but if there's any changes or any variations when the magnet comes on the poles they're pushing together, it could change the surface of that magnet. So we always grind with them on. Again, I take light cuts. And the way I have my back rail set up on this is kind of nice because I don't even have to remove it. I can leave it right on. Oh, before I do this, I want to take, because I did grind the wheel, I want to go over the squeegees too, for taking the coolant off. I got a little bit of grit and everything. If you get your squeegees, my wife and daughter, they brought the red home. I don't like the red because it seems to react with the chemicals more and it gets all mushy and gooey. The black seems to hold up a lot better. I like to have just a 6-inch, these long ones. You know, they're awkward to hold. Well, me and Adam went down to Menards to pick some up. This is what we got. We got 12 inchers. I just took them to the bandsaw and cut them down. That way, it's not big and awkward. It's just about the right size, and I can come across, scrape all the grit and stuff and the junk off. So now I'm going to come down and I'm just going to touch. kind of a heavy touch, so I'm going to back it off. You can back it off about 3/10, and I can see that I'm touching there, so I'm going to back it off even more, about 4.5, 5. I'm going to turn my coolant on. We're going to mute the sound because it's going to get loud, but I'm going to just grind, and I'm going to see what ink is left. Typically what you'll find in a magnet that's been used a lot, this area right in here will be an area that's low, and that's because people are dragging their parts off. If you have the opportunity, if you get grinding something like this, you're always better off if you can kind of break the part off rather than drag it. If there's coolant and stuff on there and it's sliding under there, you're adding the wear to your magnet quite fast. We're going to turn the coolant on, we're going to grind this, we're going to see what it looks like after just taking a few temps. I got my first cleanup pass just to see where we're at. Now I reground this magnet about a month ago, so I knew it wasn't that bad. And I have it all cleaned up except for just a little tiny bit on the end there. And I barely touch it. You can barely see any sparks. I bet it was less than 1/10 that I took off. And again, a lot of times when you're grinding, you'll see a wear point in this area. What I'm going to do, I'm just going to, at this point, I'm going to take I'm going to set my digital 0. I'm going to try to take less than 1/10. I'm going to come across, I'm going to come back, I'm going to come across, I'm going to come back. And as you see, when I was just first grinding, I went pretty fast on my traverse speed. I'm going to slow my traverse speed down. The reason I'm going to take multiple passes on there is because the grinder head right here will creep down on you. It will settle. You can see it on this digital. This digital has a 50 millionth resolution, and you can set it 0 and you can start grinding. You come across and you can see it drop 50 millionths to 1/10. So every grinder I worked on has that. I'm going to turn the coolant back on. I'm just going to finish this table out, and we'll see what it looks like with this. I have this magnet roughed in right now. Most people would stop right there. I've taken about 3/10,000ths of an inch off, and we took a picture, and I don't know if you're going to be able to see it as well as you can with the naked eye, but you can see that that whole surface on the cutting edge is loaded up. If you can contrast it, I don't know again if you see it in the picture, not with the white to the bottom of the wheel, which is darker. And what's going to happen is when it loads up, I can actually hear the grind. When I hear it grind, I know I got either dull edges or metal to metal. In this case, it's loaded, it's metal to metal. So I'm going to take retrue this wheel up. I'm going to get some fresh grit on there. I'm going to take a wood stick, a little popsicle stick, clean out the loose grain in there. I'm going to come back and I'm going to try to take about 1 more tenth off this table, and to take 1 more tenth off it, I'll have it finished. It'll be where I'll be satisfied with. Well, we just finished grinding the magnet. It came out real good. A lot of people will throw a magnetic base with an indicator, and this is how they're going to try to establish whether they got the magnet flat or not. That's not telling you if the magnet's flat. What that's telling you is the relationship between the indicator point and the center line of your spindle there. How it's in relation as you move the X. If you got a teeter-totter movement, that relationship can stay the same, but your magnet will not be flat. So anyways, I just done this. You see so many people do it. And I'll just show you the readings I got here. Adam can get up there close enough to see. As you can see, this is a 50 millionth resolution indicator. We're not even 50 millionths of an inch off doing that, but that doesn't tell me if I'm flat. A worst case scenario that you'll see a lot of people do, they'll pull their indicator and they'll stick it way out here. Well, if you got that teeter-totter effect, you're not measuring under the center line of your wheel, you're going to get an exaggerated reading. So this is even a worst case scenario. And again, it's really not going to tell you anything. So how would you check to see if this magnet is flat? I'm going to tell you the best way to check is throw some stock on there and grind it, and then check that stock on the granite table, and if it comes out flat, you got a good magnet. That's the best way. Some people will take and they'll set blocks up at multiple points, and they'll grind them. That's a better indication than what the indicator is, but still yet. Just start doing some of your work. You'll tell right away from the very first piece that you put on there. If it's grinding flat, your magnet's good. If it's not grinding flat, no matter what you're doing, you eliminated all the other possibilities that may be causing it not to be flat. Then you got to come back and start checking your table again. So some of the people who might pay close attention, when I redress my wheel, I turn my magnet off so I can remove my diamond, and I forgot to turn it on. And I started grinding, and I had the table inked up. And it was interesting because I didn't realize I was grinding with the magnet up. But I got a place here in the middle where the ink didn't come off. And I thought, well, that's strange. It took the ink off here, took it off here, and in the middle section. And Adam told me, he says, Dad, your magnet's not turned on. So I turned it on, dropped it down about another 50 minutes, come across, cleaned everything up just as nice as it could be. And so that's why it's important to grind in the magnet with the magnet turned on in the same condition that you're going to use when you are grinding your work, because it will make a difference. And I wish we would have caught that on camera, but just to save time and because it's a noisy pump, we didn't include that, but that would have been a nice thing for everybody to see. So anyhow, this is how I grind a magnet. It's not the only way. It's probably not even the best way. But this has worked for me for decades, and I've worked in tolerances plus or minus a tenth or two, and having a flattened magnet will make all the difference in the world. Everybody's got an opinion on it. It will take, if your magnet is in pretty rough shape and you need to take maybe a thousandths off to get her trued up again, in my experience, it usually takes between 1 and 2 hours to actually get this to where I'm satisfied. If you're not able to run coolant, I tell you what, it's going to be really hard to get that to this degree of accuracy. So if there's any way you can even take a 5-gallon bucket temporary and hook up coolant just while you grind the magnet, I would definitely recommend doing that. Also, make sure your coolant's clean before you grind this magnet. It makes it a whole lot easier, it'll go a lot better, and you're going to get a lot better results. Well, that will be it for today. If you like the videos, hit the subscribe button, give us some likes, we appreciate it. Feel free to make comments. I try to answer as many as I can, and I just want to again say we appreciate all the people that have been subscribing and making comments. We'll see you next time.